Hello everyone. How do large language models actually understand context? When you type a sentence into ChatGPT, how does it know what you mean? How does it connect words, resolve ambiguity, understand references? It doesn't have common sense. It doesn't think like a human. It doesn't even read the way we do. Yet somehow it gets it right. In this video, we are going to open the black box. You will see how the words talk to each other, how meaning is calculated, and how one breakthrough idea completely changed AI. By the end of this video, you won't just use LLMs, you will understand what's happening inside them. Let's begin. The problem. Here we have a sentence. The animal did not cross the road because it was tired. When we read this sentence, we instantly know that it refers to the animal. We don't pause, we don't calculate, we just understand. But a model doesn't have intuition. It doesn't know animals get tired. It doesn't know what roads are. All it sees are tokens converted into numbers. So how does it figure out that it points back to animal and not the road? That's the real puzzle. And solving that puzzle led to one of the biggest breakthroughs in AI. Self-attention. Words talk to each other. Let us look at a simple example. Apple is tasty. Here, when you hear the word apple, your brain probably imagines the fruit. Now look at this sentence. Apple's new iPhone was launched. Same word, but now we are thinking about the company. So what changed? The word didn't change. The surrounding words changed. The first sentence, the word tasty influences how we interpret apple. In the second sentence, the word iPhone completely shifts the meaning. This is exactly what self-attention does. Every word looks at all the other words in the sentence and it asks, who here is important to me? The model calculates something called an self-attention score. Higher score means stronger influence. So in Apple is tasty, Apple pays more attention to tasty. In Apple's new iPhone, Apple pays more attention to iPhone. Meaning is not fixed inside a word, meaning is calculated based on relationships. That dynamic relationship building process is called self-attention. And that's how transformers understand context. Now imagine every word in that sentence sitting in a meeting room. Each word can look at every other word. When the word apple appears, it looks around and asks, who matters to me? In the first sentence, the word tasty is important to understand the context. In the second sentence, the word iPhone is important. The model calculates something called an attention score. Higher scores mean stronger connection. Stronger connection means more influence. For example, in the second sentence, the word Apple gives more weight to iPhone and less weight to new. This is self-attention. Every word checks every other word, all at once, not one after another. That's powerful. But wait, what about order? Here is where it gets interesting. Transformers don't read left to right like we do. They process everything in parallel. So without extra information, dog bites man and man bites dog would look identical. That would completely break meaning. So we add something called positional encoding. Think of it like GPS coordinates for each word. Now the model does not just know who you are, it also knows where you are in the sentence. That's how order is preserved. The transformer block. Now let's zoom out. First, words are converted into embeddings. Then positional information is added. Then self-attention calculates relationships. Then a feed-forward layer refines those relationships. And this entire process is stacked again and again and again, layer upon layer. This architecture was introduced in 2017 in a paper called Attention is All You Need. That paper didn't just introduce a new model, it sparked the modern AI revolution. Almost every large language model today is built on this idea. The big idea. So what is really happening under the hood? The model is not thinking, it is not conscious, it is not reasoning like we do. It is calculating relationships. Self-attention decides which words matter more. Positional encoding ensures order is preserved. Stacked layers refine and recombine meaning. And what emerges feels intelligent. But underneath it all, it's mathematics operating on vectors and matrices. And that mathematical structure is the foundation of every modern LLM. Let us take a step back and see how far we have come. We started with the basics. What is AI? What is machine learning? What is generative AI? What is an LLM? Not in complicated academic language, but in simple practical terms. Then we went deeper. We explored neural networks, how models actually learn patterns from data. Then we went deeper. We broke language into building blocks. What are tokens? What are embeddings? What is a vector? How text becomes numbers? And today we went even further. We understood self attention, how words decide what matters. We explored positional encoding, how order is preserved even when everything is processed in parallel. These are the core ideas behind transformers, the foundation of modern large language models. If you haven't watched the earlier videos in this journey, you can find them in the Decode Tech playlist. They are designed to build step by step. Now, when you use AI tools, you're not just seeing output, you understand the architecture behind it. And this is only the beginning. The next videos, we will keep decoding AI clearly, simply, and logically. Stay tuned. Thanks for watching. If this video helped you even a little, please hit like, share it with friends, and subscribe to Decode Bro for more insightful content. Stay tuned for the next video. Until then, take care.